Today we're going to learn how to find arc lengths and area of sectors. Now you may remember in the last unit we found out how to find the measures of arcs in degrees. Well, now we're going to find the length of arcs, in other words, part of the circumference. So here we go. We're going to start with recalling a little terminology. The distance around the circle, of course, you know, is the circumference of the circle. We could also call it the perimeter of the circle. That's okay, but typically since it's a circle, we refer to its perimeter as the circumference. A portion of the circumference of a circle is what we learned about in the last unit, known as an arc. So, of course, here's what we're talking about. Here's a circle, and if I were to draw two radii, this part here that's bounded by those two radii, that would be an arc of the circle. All right, and the theorem, which you've known for a long time, is that the circumference of a circle is pi times the diameter. And now what we're going to learn is that arc length is a fraction of the circle's circumference. And hopefully from this little picture here you can see that it's a portion of the total circumference. So I think it's going to be kind of intuitive to you how we're going to go about finding arc length. But let's do a little example here before we look at the formula for it below. So we got a circle, we got a central angle measure of 60 degrees. Of course we know that's, well, hold on, I'm not going to spoil the fun by talking too fast. 60 degrees, we got a radius of 5 inches. So let's get that picture drawn there. You want to find the length of the arc. So here's what I want to do. I want to find out what fraction, and here's the arc I'm talking about here. I want to find out what fraction of the whole is that. Okay, well I know that arc is a 60-degree arc, right? I know all the way around the circle is 360, so what fraction of the circle is that arc? So let's say this. Let's find the fraction of the circle that the arc is. I'm sure that's not good English, but hopefully you know what I mean. So how do I do that? Well, I know the arc measure is 60 degrees. I know the total measure in degrees of the circle is 360. So what is that as a fraction? It's 6 over 36, which is 1/6. So that arc there, that red arc, is 1/6 of the complete circle. So then how do I find out what its length is? Well, I got to find the circumference, right? I find the circumference of the circle and then multiply it by a 1/6, and I'll have the length of the arc. In this case it's a 6, but in any circle all you got to do is find the fraction that the arc is and then multiply it by the circumference. So what is the circumference? It's pi times diameter, or 2 pi r, which is 2 times 5 times pi, so that's 10 pi. So what we got is our arc length, and I'm just going to call it little l like that, is 1/6 times 10 pi. And then if I simplify that, let's see, 2 goes into 6 3 times, goes into 10 5 times. So 5 pi over 3, and let's see, we got inches there. So 5 pi over 3 inches would be the length of that 60-degree arc. Okay, and here's the formula that tells you the formal theorem, but I wanted to do that example for you that way so that you really don't have to memorize this formula here. All you got to do, find the fraction that the arc takes of the circle and then multiply that by the whole circumference. Okay, we got some practice problems here. So let's take a look at a couple of these. Find the length of each arc. Okay, leave your answers in terms of pi. That just means my answer is going to have pi in it. I'm not going to take the time to go punch it into my calculator and get a rounded off decimal. All right, so what did we say we want to do first? We want to find out the fraction that this arc makes up. So the fraction is going to be 70 over 360, right? That arc is 70 over 360, which is just 7/36. And then remember, I got it, well, let me not put that there. That's not quite right. And so remember, to get the length, I want to do that fraction times the total circumference, which is pi times diameter, which is going to be 8 pi. Okay, and let me simplify here. Let's see, 4 will go into 36 9 times, go into that 2 times. So what I get is 14 pi over 9 millimeters. And it's length, so not squared. We're not talking about area at this time. Okay, so I've got 4 or 5 more here. I want you to pause and try to do these, and as always, I'll come back and have the answers up for you. Okay, and the second problem, same thing. We got to find the fraction that arc is, and that's 100 over 360, and then I just plug that right into the formula. 100 over 360 is 5/18, so this arc right here, 5/18 of the circle, and then I multiply that by the total circumference, which is 14 pi, and I get my answer there. Same thing for the circle below, exact same steps. And then down here, a little bit different, we got the wheel of a compact car, 25 inches, and the diameter of a pickup truck wheel is 31 inches, and I want to know how much farther does the pickup truck go than the car if each wheel just does one revolution. Well, the distance traveled in one revolution would be the circumference of the tire, right, or the wheel. So if I were to cut that thing and lay it out flat, it would travel that distance of one circumference in one revolution. So that's the thing you got to know here. So I just calculate by using the formula for circumference for both the compact car, so the circumference of the compact car, the circumference of the truck, and I get a difference of 6 pi, and they asked me to round that to the nearest inch. Right, so I plug that in 19 inches. And then down here we got this poor little hamster who's going to run his little legs off because he doesn't know any better, because he can't go outside. And I find, so the same thing here. I know that one revolution is one circumference, so I find that distance, which is 7 pi. Okay, well, he's going to do 100 revolutions. In real life, I think they do maybe thousands and thousands of revolutions in a day. But I guess this was just a step at a time. So this guy, he does 700 pi inches in distance with 100 revolutions, but they ask me round to the nearest feet to the nearest hundredth. So I got to convert inches to feet. Well, there are 12 inches per foot, so I got to divide that by 12. And then when I do that and punch it in, I get about 183.26 feet that the little hamster is going to travel if he runs on that thing 100 times. All right, so now that takes care of arc lengths. Now we got to look at areas of sectors. And to do that, we want to recall that to find the area of a circle, we use this formula, pi r squared. It is a theorem. It's in your book. You probably don't need to make a card for that because you've known that since you were 2 or 3 years old, probably. All right, maybe 2nd or 3rd grade or 4th. I don't know. Find the area of a circle. Okay, so this is just review. So I got a circle. It's got a radius of 32, so the area is pi r squared. So 32 squared times pi, which is, I don't know. I didn't punch that in, but you can square 32, and then it'll be, what is it, feet squared. Go ahead and punch that in if you want to. You don't have to, though. It's not important right now. What we're really interested in is a sector of a circle. Okay, and here's what a sector of a circle looks like. So if I start at the center, and this is an arc here, right? We know this is an arc. All right, if we look at this whole region here, this whole region would be a sector. So I'm going to figure out how to find the area of that. And I put you a little note here that said, hey, a sector is when you eat a piece of pizza, that's what you're really eating, is a sector, right? So you got your little crust here. You got your little, I should draw mushrooms since I'm a vegetarian. A little mushroom. Okay, so there's your pizza. That's a sector. So you know what? Next time you order pizza at home, you go, hey, Mom, could I have another sector of pizza, please? Okay, so how are we going to find the area? Well, it's kind of like we did with arc length. What do we want to do? We want to find out what fraction of the circle is this sector. So how do you suppose I'm going to do that? Well, let's take a pizza example. Everybody knows about pizza. Suppose you ordered a large pizza and it has a 16-inch diameter. So we'll just use this pizza right here, pizza. What's your favorite pizza? I like Victor's Pizza. We're going to say this came from Victor's Pizza. Okay, and what do we got? 16-inch diameter. Okay, I don't know if that's really a large or not, but it seemed like a good number. And it's cut into 8 pieces. Oops, this one, let me draw another picture. I need 8 pieces. You go ahead and draw this too. So that's 8, because the diameter is 16. Let's say you're going to eat 2 pieces. I know you're probably going to eat more than that. And of course, all these pieces would be congruent, but you know, they're never really that way when it comes from the store either, right? So you're going to eat 2 pieces. You're going to eat this much that I've highlighted in green. How do you find the area of the pieces? Since each piece is a fraction of the whole, we need to find the area of the whole pizza first. So area, I'm going to say total, is pi r squared, which is going to be 8 squared times pi, which is 64 pi. Inches, square inches. Okay, so there is the area of the whole thing. Now what we want to do is find the fraction that we ate. Well, we know because it's cut into 8 pieces and we ate 2 of them that that's a fourth. So I can use that in this problem. Sometimes I won't have it cut into pieces, so we'll have to do that a different way. Oh, sorry, I wrote this as another step. Let me just get rid of this here. You need to find the fraction you ate. Well, I know I ate 2/8, which is 1/4, but I could also do this by using central angles, right? So we better do that because it's not always going to be cut into pieces. So what I know is if I got 8 pieces, then I want to do 360 divided by 8, which gives me a central angle for each one of those pieces of 45 degrees, right? For each piece. So each piece has a central angle here. I'll mark it this way. Central angle 45 degrees. So if I eat 2 of those pieces, it's going to have a central angle of 90 degrees. 45 times 2. 2 pieces have central angle of 90 degrees. So then if I didn't have them cut into pieces, what I would do is I'd say, okay, the fraction of the pizza that I have is 90 over 360, right? 90 degrees over 360 degrees, and I could get my 1/4 like that. And more often than not in the problems you're going to do here, you're going to have to use central angles because it's not going to be cut into pieces. Okay, so I got 1/4. So now, just like I did with arc length, I want to multiply. So when I want to find the area of the sector, I'm going to multiply the fraction that I'm eating times the total area, which would we get there? 64 pi And so that's going to give me 16 pi square inches. Or does it ask me to round it? Let me see what it says. How would you find the area? It didn't ask me to, but I actually did it here on my paper. This is approximately 50 square inches of pizza that you ate if you're having 2 pieces of that pie. Okay? And so here is the theorem with the formula, but hopefully since we went through it this way, you don't really have to memorize this formula because the steps we did were what? Number 1, we found the area of the total circle. Number 2, we find the fraction of the total circle that we're trying to find the area of, and then we just multiply those two things together. So let's do a little bit more practice. What is the area of the shaded part here? Well, we know that's a sector, and we know we got to take that fraction, which is 72 over 360, and we got to multiply that by the total area, which is 15 squared times pi r squared. All right, and if we were to punch all that in, let's see, 72 over 360, oh, that's 1/5. So that's going to simplify to 1/5, and that'll be 225 pi. And 5 definitely goes into 225. So my area ends up being 45 pi square centimeters. Okay, here's another type of question you might have. It says in a circle, a 90-degree sector, I know that's a fourth, right? 90-degree sector, right there. 90-degree sector has an area of 36 pi square inches. What is the radius? So that's what we're trying to find this time. So we're still going to use this formula that says the area is going to be 90 over 360 times pi r squared times the total area. Okay, but hey, what else can we plug in? The area. We know what the area is. The area is 36 pi, and that equals, we know 90 over 360. I'm going to go ahead and simplify that, times pi r squared. So now I just got to solve for r. So what I want to do is I want to multiply both sides by 4 to get rid of that 4 right there. So when I do that, let me come up here, 4 times 36, that's 144. So 144 pi equals pi r squared. And then if I divide both sides by pi, the pi is just going to be gone. So I got 144 equals r squared. So r is plus or minus 12, but of course it's not negative. It doesn't have a negative radius. So the radius has got to be 12 inches. So another fun type of problem you might see in the future. Okay, so finally, let's talk about a segment of a circle. I know when you think a segment, you think of a line segment, but this is a little bit different. When we talk about a segment, it's a part of a circle that's bounded by an arc and the segment joining its endpoints. Okay, so here's the arc and here's the segment. So this little part right here is a segment. That's a segment of a circle right there. So you got a sector. So what do you think you would have to do to find the area of a segment? Well, what you would do is you would find the area of the sector, right? We just did that. Find the area of the sector. And then 2, you would find the area of the little triangle right here. Here's our triangle. And then 3, you would subtract the area of the triangle from the area of the sector. Okay? And there's a little key concept note that I posted for you right there that says the same thing I just told you. So what I think I have here is one problem to do with you and then a whole bunch of practice for you to do. And I apologize, this is a long lesson. Sometimes that's just the way it goes. Sorry. So let's do this example together and then you're on your own to get the rest of these done. What's the area of the shaded segment? What's the area of the segment? Okay, what did we say we got to do? We got to find the area of the sector first. So area of the sector is 60 divided by 360 times pi r squared. Let's see, my radius is 18, so 18 squared times pi. And so that is 1/6 times 18 squared times pi. And that comes out to be 54 pi when you simplify that. I believe that's right. Double check me. Let me know if I made an error. Okay, so now I got the area of the sector. Now I need the area of the triangle. And look, I know that this is also 18, right? Because they're both CA and CB are radii. And what I can do is, well, I know these two are congruent, right? These two are congruent. Therefore, I got an equilateral triangle. So I can easily find the area of the triangle by using this handy dandy little formula. Square root of 3 over 4s squared times 18 squared. And when I simplify that, I get 81 times the square root of 3. So now I just got to subtract, right? Subtract the area of the triangle from the area of the sector. So the area of the segment equals 54 pi minus, 81. 81 times the square root of 3. And that's all I can do. I can't simplify that. I can't turn it into a decimal. They didn't tell me to, but I'm going to round it off to the nearest hundredths, and that's about 29.35 square inches. Okay, practice problems, do those. I'll come back and have the answers for you when you're finished. Do them all. You need to practice. All right, these first two practice problems, pretty straightforward. I just needed to find the percentage or the fraction of the circle, not percentage, the fraction of the circle that is shaded. In the first case, since this is 90 degrees, I know that 360 minus 90 is 270, so I just plug that right into the formula, get my answer there. Second case, I did the same thing. If I've got the whole circle minus 45 degrees, that's 315 degrees. And so 315 over 360 is 7/8. That shaded part is actually 7/8 of the circle. So multiply that by the area of the whole circle. Down here, I am finding the area of a segment. So I first need to find the area of the sector, then find the area of the triangle, and subtract the area of the triangle from the area of the sector. And when I worked all that out, I had to come in here for this triangle to find the area of the triangle. I had to find the height of the triangle. Okay, and so since I knew that this central angle was 120, when I divided that in half, I knew that this angle here was 60 degrees. So that means this one had to be 30 degrees, which is this one right here. So you really got to break those little triangles out and draw them larger. And then I used my special right triangle rules to find everything I needed to find the area of that triangle. And I wrote you a note right here that if this were a calculator problem and you were asked to round your answer, then you could have used this little formula right here that we learned last time, I think it was, to find the area of that triangle. And then you just subtract. You subtract, and since I can't simplify this anymore, I'm going to leave my answer just like that. All right, in this problem, what I realized I needed to do was I needed to find the area of the shaded sector that I cross-hatched in green. So I did that first. Then I found the area of the triangle, which I did. It's just like the one in the previous problem. If the green central angle there is 240, then I know that this has to be 120 degrees. So when I go to find the height of it, it gives me a 30, 60, 90 triangle. And then I got to add those two, right? I got to add those two together. So I found the area of the sector, which was 54 pi. Area of the triangle, I got 81 times the square root of 3 over 4. Add those two. All right, and then down here, I didn't work these because I wanted to be sure that you guys are developing the skill to do it without looking at every step that I do. So here are the answers that I got right here for that one, and right here. You could leave your answer this way, or you might see it put together as one fraction that way. But please do those problems and make sure that I got my answers correct. And we'll see you next time when our lesson is on geometric probability, I believe.